So the last part of this problem is asking us to figure out what is the velocity of the ball just before it hits the ground. Conceptually, if I throw this ball into the air with some initial velocity, in this situation it was 20 meters per second, and it has gravity pulling down on it, right? So it has an acceleration in the negative direction. It goes up, it turns around, it comes back down, and the only thing acting on it is still gravity. Because we went the same distance, my final velocity should be 20 meters per second. But let's show that mathematically. So, there are a couple different ways we can go about this. I am going to use my velocity at the top of this motion as my initial velocity, because I think that's simple, it helps me, it's 0, things will cancel out. My final velocity, right, this is what I'm solving for. I know that my initial position is 20 meters, my final position is 0 meters, and I have an acceleration that is negative 9.81 meters per second squared, and I know that the time it's going to take to go from its maximum height to hitting the ground is going to be 2.02 seconds. So now I need to figure out what equation I would like to use. I have a lot of information here, which means that I should be able to use almost any of these equations. So let's first start with seeing which ones don't involve final velocity. The first one has this average velocity, meaning that the final velocity is contained in there. I could use equation 1. I could use equation 2. I cannot use equation 3 because the final velocity is not in that equation, and that's what I'm solving for. Or I could use equation 4. I feel like I've used equation 2 a lot, so I'm just not going to use that one. I'm just personally not a huge fan of equation 1. I don't know why. Personal preference. I'm not fond of it. There's nothing wrong with it. It's a perfectly fine equation. I just don't like it. So I'm going to use equation 4. And I think that equation 4 will be a good demonstration because we also have this final velocity squared, which means that we'll have to determine if it is a positive or a negative value. And actually, let's go ahead and solve it with equation 4, but we will confirm that our answer is correct with equation 2. So again, we're going to do this problem twice. So equation 4 has that our final velocity squared is equal to our initial velocity squared plus 2 acceleration delta y. This delta y is going to be important to think about conceptually because this is something that students mess up on a lot, and I understand why. So let's think about, well, let's go ahead and plug in some numbers because we already have our final velocity on the left-hand side, right? So our final velocity is going to be equal to plus or minus the square root of my initial velocity squared, that's 0, plus 2 times my acceleration, which is negative 9.81, times this delta y. So what is my delta y? A lot of students put in that delta y is equal to 20. This is not correct. That is not correct. And that is because this object is falling, right? So my definition of my change in position on the y-axis, right, my delta y, is that it is y final minus y initial. Well, my y final is 0. My y initial is 20. This means that my change in position on the y-axis is going to be negative 20 meters. And this makes sense because the object is falling down. It's moving in this negative direction. So I have to make sure that I have this negative 20 contained within there. One way that you'll know that you've made a mistake and that you should really review the directionality of the numbers that you have put into these equations is if you get a negative inside of that square root, right? The square root of a negative number gives you an imaginary number, and we are not working with imaginary numbers in general physics. So if you get a negative inside of your square root, double check that you have the correct directionality for your variables. So let's go ahead and just punch this into the calculator, right? And we get plus or minus 19.8 meters per second. I said it was going to be 20. We're close enough. That's within rounding. So now we have to make a decision. Is our final velocity positive 19.8 meters per second, or is our final velocity negative 19.8 meters per second? In order to determine this, it's not as easy as it was with time, right? With time, we know that time is always going to be positive because we can't have negative time. But whenever we have plus or minus the square root of some value that is giving us the velocity, we have to consider the directionality that this object is moving. So whenever we have a positive velocity, our object is moving in the positive direction. Whenever we have a negative velocity, our object is moving in the negative direction. So because this object is falling, we know that our final velocity has to be negative 19.8 meters per second, because that negative sign tells us that it's moving in the negative direction. So it cannot be the positive value. We can double check this with equation 2, right? So equation 2 was final velocity is equal to our initial velocity plus acceleration times time. We should automatically get the directionality out of this equation because there is no square root, meaning that the answer that we get should be negative. And we get negative 19.8 meters per second. So this is the solution. Both of them are correct. And either way you choose to approach solving this problem is perfectly fine. Both of these are valid and correct ways to solve the problem. Honestly, just go with whatever one makes sense to you. And oftentimes, I just pick one